Welcome to the second talk of this GCP Meetup. This one is about a bit of a different topic. So it's mainly about managing cloud resources using Kubernetes. So to start, I'll present you with the problem. So basically, we want to provision some infrastructure that supports our applications. Pretty common use case. Like a developer needs a database or something. So yeah, before we start, just a short question to the audience. Who in here is using Terraform to provision infrastructure? Yeah, like 5 hands, okay. Okay. Who is using, sorry? Puppet Chef, okay, yeah. Another choice. Who is using the Google, oh God, I forgot. Yeah, I even forgot how it's called.
Deployment manager.
Deployment manager? Is it that?
That's for all resources. This is the Kubernetes one, right?
Yeah, no. I'm talking about the generic one.
Oh, okay.
Yeah, who's using that? Okay, at least one. Who's using G-Cloud and Bash? When needed, some people. Okay, that's okay. I just wanted to know. So yeah, so I guess you face this problem. Some developer wants to deploy his app on GKE or maybe even compute engine, but in the end, he requires a Postgres database. So what do? Well, we have different choices here. The developer could just go to the console, click together his database. Yeah, well, this is bad because he probably doesn't know what to properly set, what kind of parameters are important. Yeah. Second option, developer asks infra operator to provision the instance. So kind of like a internal service if you have these kind of roles in your company. This is better, but there's still no clearly defined interface. I mean, the developer could just say, I want a database, and then the other guy asks, how big is it? Yeah, it might go back and forth quite a bit until the database is properly configured. So yeah, self-service is simple, right? So, I mean, we could do it like that, just give everyone owner access in the GCP project, problem solved, no need to worry, they can just click what they want. But yeah, as you might imagine, that's not a great idea because there's gonna be people which configure a database which doesn't do any backups. They might configure a database that has shared core, that isn't supported by an SLA, stuff like that. It seems simple at first to click stuff together in GCP, but there's a lot of small details that are important, and you need to get them right. So yeah, a sane self-service approach, what would that be? So we need to first know what do we actually want. So yeah, that's obvious. We want to deploy the infrastructure together with the application. What does that mean? We want it to be closer to the application. So what would be great is if we didn't have to invent a new workflow. So if the developer deploys his application, he can use the same kind of mechanisms to deploy the database that he needs for the application. That would be great. Yeah, it would be great if we could set useful defaults. For example, the backup thing. So every database that gets spawned automatically has backups enabled. It automatically sets a good maintenance window, stuff like that. We want to have some separation of concerns. What that means is, for example, it depends on the company, of course, but usually you have this developer role and then you have the infrastructure role, and they don't need to both know all the details of each other. It's just too much stuff to know. So the developer knows his application stuff, the infra guy knows his databases, knows his parameters, stuff like that. So we need to have some separation there. We actually defined these 3 roles. I mean, these aren't like hard defined roles. It's just an example. Could be different in your company. But we have the infrastructure operators. They're the ones providing the infrastructure and services. Then we have the application developers. They just build the application independent of infrastructure. I guess it would be nice if it were that way. And then we have the application operators. They're the ones just in the end deploying it. So they know they're kind of in between. So how can we solve this? There's different approaches again. Oh, I forgot one point. Yeah, have clearly defined interfaces. What that means is, for example, yeah, the example that I had before with the developer asking the infrastructure operator, you need to have some clearly defined interfaces, what is possible, what can be provisioned between those roles. We'll see what that means later. So yeah, how do we implement this? That's one way. It's actually what we did at 9, or what we kind of still do at 9. So the infrastructure operator, he writes a Terraform module, and he basically provides that Terraform module as the interface. So the application operator, he can define some parameters, but the details are hidden behind this module. So there's still a downside to this. It's still a forced workflow. That means the application operator still needs to know Terraform, because he still needs to work with Terraform. He needs to write that module block. He needs to Terraform apply somewhere. It's still not super integrated into the development workflow. Yeah, another idea would be use config connector or crossplane. Why? Well, it kind of fits into that workflow thing, because in this scenario, we're assuming you're already running on Kubernetes, right? So you know Kubernetes resources, you can work with them, you have a workflow established to deploy stuff on Kubernetes. So why not use that? So yeah, config connector versus crossplane. What is config connector? That's a Google product. I think it's GA since 2 weeks or so. Still pretty new. And it's basically, it allows you to provide some custom resources. So a normal resource definition in Kubernetes to spawn certain GCP resources, for example, a database. Crossplane does actually the same, but yeah, I'll get to what it does later. So yeah, both can provision GCP infrastructure with Kubernetes definitions. That's like the basis of them. So you can define your YAML, have your database, whatever. I'll show more of that later. So let's compare them. Config connector, it has a more complete catalog. I mean, it's developed by Google, so they kind of implement almost every resource that GCP has to offer, so that's great. It is GA, only recently, but it's now GA, so you can actually use it in production, and it's supported, I guess. If it's GA, I didn't try. Crossplane is still in beta. There's still a 0.12 release or something. It only has a few core GCP resources to date. But it's an fully open source project. So if you just look at this config connector, if you're on GCP, it looks better. But there's some things that config connector doesn't have. So we'll go over this now. So yeah, what makes crossplane stand out? I've talked about this before with this separation of concerns. So with config connector, you don't really get that, because the developer still just defines his database, and he needs to know all the details. He needs to know every parameter he needs to set. It's basically the same as if you make an API call to GCP. You just do it via Kubernetes, but there's no abstractions. And yeah, that's kind of bad, because in Kubernetes, you have these abstractions. You define a deployment. It creates a stateful set. It creates a pod. You don't need to know the details about the stateful set, pod stuff. You just want a deployment. And that's what makes Kubernetes so great. Well, I mean, it's still complicated, but yeah, you get the idea. So Crossplane is multi-provider, so anyone can develop a provider actually. Yeah, you can even write your own. Currently there's Azure, GCP, AWS, all the big ones, I guess. And yeah, they're expanding a lot. They have this composition model, and that's where it gets interesting. I'll show a lot more of that. But basically, it provides that separation of concerns, so you can really have some abstractions in your configuration. Yeah. So basically, Crossplane allows us to build a whole platform in a declarative way. So it's still mostly just YAML. Of course, if you want to build your own provider, you have to write some code, some actual code, Go, or you could write, actually you could write any other language that interacts with Kubernetes, but usually it's in Go. But yeah, as a platform operator, I could build a lot of stuff without writing code. And it benefits from all the reconciliation benefits that you already get with Kubernetes. So for example, if you define something in Kubernetes, it will keep on making sure that it's running. For example, if something is not ready yet, it will just retry. There's this whole loop of things happening, and you get that for free. So with Terraform, for example, if you're familiar, you run it once. You like say Terraform apply, and if there's an error, you've got to rerun it. You could do this in a pipeline, and yeah, but you can do retries in a pipeline, but if there's some API error or configuration error, it's just going to fail, and you have to fix it manually. And you basically need to have all the dependencies. You need to know about all the dependencies, or at least Terraform needs to know about all the dependencies beforehand, before it can even run. So that's different from the Kubernetes model, where you just define something, and if it's not there yet, it will just wait and retry if it until it's there. So yeah, I talked a lot, and you probably have no idea what I'm talking about. So I'll better show you something. So yeah, let's switch over. What do we have here? I'm just going to show a basic example for now. I'm going to actually start this because it takes quite a bit to run. But what we have here is a locally running Kubernetes cluster. It's not even running on GKE. And I installed Crossplane on it. I installed the GCP provider. You need to install a little configuration to make sure that your Crossplane can connect to GCP. You need to configure a service account. You need some permissions. But yeah, that's all done. You don't need to know the details. So basically, what I want now is I want my app. I'm a developer. I just have a requirement basically to deploy my blog. I took an application called Ghost. It's just like an open source blogging software, just to demonstrate it. It could be any application, but basically, I'll actually use the other one. I basically want to deploy a blog, so I have this kind defined, and this is already a Crossplane resource. So this is what the developer would see. He would just want a Ghost requirement. That's the kind. There's some metadata, so he'll name it cluster blog, namespace, and other than that, he just needs to know a few things. He needs to know how much storage does he need. That's for the database. He needs to set a blog name, and he needs to set a version. And this selector is just there. Basically, we want a beef log. So we have the selector type cluster. So it will spawn its own cluster. So as a developer, I don't need to know that much, basically. And these parameters, they can be configured by the platform operator. So he should configure those or just expose the ones that are important to the developer. So I'm just going to go ahead and create this. I can just use the normal kubectl, create, and yeah, that's it. It's going to be created now in the background. While it does that, I'm actually gonna, yeah, I'm gonna do that. So what this does, it actually spawns a whole Kubernetes cluster in a new network on GCP, then installs the blog with Helm. And in the end, there should be a local answer where I can just access the blog. And
the database is on like Postgres from GCP?
Yes, thank you. The database is also there. That's Cloud SQL, Postgres. No, MySQL. Ghost needs MySQL.
No, but you're talking about Cloud SQL on GCP, or is it
Cloud SQL on GCP?
Okay,
yeah.
So it's a GCP resource, not a Kubernetes resource.
It's both.
Fine.
So I also have Cloud SQL instances. You can see it. 55 seconds ago, pending create. That means Google is working on it. I can do gcloud SQL instances list just to show you. There it is. It has the same name as in Kubernetes. It's pending create. So the state is synced, right? So that's what it does. And now while this is doing things, let me open my editor. Oh God, this is small again. Okay, so let me show a bit behind the scenes what's happening. So as a platform operator, I need to define these things so the developer can use it, right? So the developer used this YAML file basically, but to define this, I need to first write a composition, and that's where it gets a bit complicated. But I mean, you're the platform operator, you're used to complicated stuff, so yeah, why not? It's your job. So basically, what he does is he writes a composition, and we don't need to go over all the details, but basically here you specify all the resources that are needed. First, I create a API version compute.gcp network, so a GCP network. I create a GCP subnetwork that's just for the Kubernetes cluster. So we have a pods and services subnet range. You specify the actual GKE cluster, sorry. In here, you can define all the details. I didn't specify that many parameters. There's like 100 parameters. So yeah. And oh yeah, there's the node pool, small detail. Cloud SQL instance. And in the end, there's the actual Helm release, which will deploy the block. And all of this, Crossplane is gonna figure it out and basically connect all of these using mainly Kubernetes secrets. So for example, the Helm release, the Helm provider will know how to connect to the newly created cluster via a Kubernetes secret. And then, of course, the blog needs access to the database, right? So what do we do here? We just say, so the external database host is taken from a secret reference. So we actually access the secret that Crossplane creates. And yeah, there's some settings just for the blog, doesn't matter. Yeah. So this is one resource I have to create. And then I also have the infrastructure definition. That's basically to define what can be configured by the developer. So in here, you have all these parameters that I set before. There's just version, storage, blog name. That's basically it. And then there's the publication. This will actually make it public, so available for the developer to use. And all of this is subject to change because Crossplane is subject to change. But yeah, the basic ideas are gonna stay. So let me just go back here and see. Okay, the cluster is ready, but still reconciling, I'm guessing. I can also just get node pools. Yeah, the node pool is still provisioning, so the cluster has already been created, but the node pool is still provisioning, and I guess the SQL instance is also still provisioning. Takes about 5 minutes for the cluster to be set up, and around 8 to 10 minutes. At about 8 to 10 minutes, the Ghost blog should be up. Yeah, that's basically it. You can just abstract away these things. And I actually made a second version. So I've shown you, like, here I have the type cluster, which means I want a beefy block, but you could just say, I want the same thing, but with type local, and that will actually use the composition that is specified with local. And this will just deploy it inside the existing cluster. So it's a bit more reasonable. The other thing, having a cluster per block is probably not reasonable, but it's just to show. So yeah, let me get back to the slides. We will get back to the demo afterwards. Just have one more thing to show. I stole this from a Crossplane presentation last week. There was a KubeCon presentation, and it was really, it really captured what they're trying to do. They're not just trying to do, they're not just trying to replicate what the config connector does. They're trying to build a whole new thing here. So basically, as a platform builder, like right here, you can basically define these new APIs. Using your cloud provider, using your on-premise stuff, it doesn't matter. You can write your own, right? So in the end, as a platform builder, you can use Crossplane to build all these things, and your consumers, which are maybe it's a developer, maybe it's another platform guy, it doesn't matter. He can use his existing tools to use this API, because in the end, the Kubernetes API is just a REST API. So he can basically use the same tools that he's used to. So for example, you could even go as far and use Terraform again. So I define this cluster spec and this really special cluster that I want, or my consumers want, and they could provision it with Terraform because they're using Terraform for everything else already. So yeah, you could basically do anything like that. And I can also show that a bit. So I'm not sure how many people know this, but you can just proxy to with kubectl, and now you have just API access locally, unauthenticated. Sorry. So now let me just. Oof, do I still have that? I don't have it anymore. All right, doesn't matter. I'll do it differently. Let me just go on GitLab, because there's this really neat thing I discovered today. All right. So yeah, I noticed this really neat feature of GitLab. Yeah, there it is. So what you can do with Kubernetes, you can via the API. What is it? 8001. You have this one API endpoint. There's so many. Yeah. Open API /v2. What this is the open API spec of your cluster, of your current cluster. So basically what this means is, let me just export this again so I have it current version. Oh God. Okay. So what this means, you can view it with any open API compatible viewer. And as it turns out, GitLab has that built in. I've realized today. You could also use Swagger UI if you know that. And what I have here is my whole API documented. So it's a bit long because it also includes all the internal APIs of Kubernetes, but I can just search for 9 here. And here I have actually my ghost requirements. So yeah, my browser is getting slow because this document is so huge, but you get the idea. I've my API documented of my ghost requirement. So I could even just give this out to developers, like, here, provision your stuff. So yeah, I think it should be ready now. Releases. Yes, so releases is the Helm release. There's an old one laying around, but the one that's deployed 10 minutes ago, that sounds about right. So let's just go to the Google Cloud Console. Because I don't want to log into this new cluster, it's just going to mess up my kube context. So I have clusters. So I got this new cluster blog. It has the same name as I basically chose with a suffix. And here I have services in ingress. It's just to really get the service. I guess this is the wrong one. Okay, yeah, there it is. Yeah, that's it. It's deployed. So GCP news, and in the end, that is the title of the blog, and that's actually the same as here, blog name. So yeah, it's just a proof of concept. I mean, you're realistically not going to deploy a whole cluster, but you could. So yeah, that's about it. I think I have one more slide. So what's next? This is very cutting edge. Because Crossplane, I mean, they have been around for some time now. I think they started in 2018 with the project, but they've made so many changes to the project and went into different directions. And this is a best example of this. I was preparing this talk last Friday, and I did all these infra definition, infra publication resources and stuff. And then I see this pull request, replace that with a new type. So basically everything I've showed you will change again, but the concepts behind it will stay. This hasn't been merged yet, by the way. I think might be merged tomorrow. So yeah, but they're planning on having some stability. There's actually an issue now which says we want to have 1.0 shipped, and from there on there will be some API stability, so you don't get these changes every day. Yeah, so watch this issue. I guess we will publish the presentation anyway, so you can click the links then. And yeah, what we will do, we actually wanted to do this. We wanted to give this to our customers, because we have customers there. They have to come to us to order a database, and it's just annoying. So we wanted to make this available, and we were about to launch it, but then we've seen that Crossplane again made these huge changes, and they didn't provide a stable API. So we said, okay, let's wait, because else I don't know where we would be right now. It would be bad. So yeah, after 1.0 ships, we want to ship it as well. And yeah, watch our blog for updates. That's it. Thank you. Any questions?
Or pizza.
Oh, we can do pizza, and you can ask me questions while eating. Yeah, I don't mind. Yeah.
MySQL 5.6 on this database memories.
Was it 5.6? I don't know. Oh, I guess it's the default. Yeah.
Okay, but maybe one, like before pizza.
Okay.
So you showed Crossplane and the conflict connector, right? Technically, with both, you can request a database cluster from Google, which will spin up a Cloud SQL instance for you. Both of them will be viewable through your Google Cloud cluster.
Yes.
The biggest difference was the fact that on Crossplane, you can define your composition, which as a result allows you to define a limited number of values that your developer can change.
Yeah.
You are a GCP shop. If you could have, for example, a small, like let's say, reconciliation operator, such as like operator framework Helm operator, that basically takes the entire CRD of config connector and limits it to like 4 values that your customer can change. What would you rather use? Would you use Crossplane with its composition API, or would you use config connector with like a custom reconciler operator?
Yeah, I mean, you will probably end up just writing the same as Crossplane already does. I don't know.
One is stable.
Yeah. That's a good point. But it's open source. On the other hand, you could just say, okay, go contribute, go make it ready, in an open spirit. But I guess you could develop your own, but we haven't tried. I mean,
so you'd rather choose Crossplane?
Yeah, I think we'll try to contribute, try to get it to version 1 and then use it. Because
I'm happy to hear like support for Crossplane, but the whole point of Crossplane was that you could request this cluster from like every single like cloud provider.
The thing is, you could actually use config connector with Crossplane, theoretically. Yeah, because in this definition that I showed, you can specify any Kubernetes resource. So in the end, there's just some minor details there that need to be figured out with the status. Like you need to know if it's up and running. Crossplane needs to know it. But other than that.
Yeah, but if you're just on Google Cloud, it doesn't really like. Why would you use Crossplane, which is really born to be cross-cloud?
Yeah, because I guess in today's environments, you will probably need to provision other stuff. I mean, like you said, Helm, you can't use the config connector to provision Helm stuff, for example. So yeah, it's just, I guess Crossplane is just more all around. You can use it for anything basically, and that's, I think, what makes it interesting. But yeah.